record that one. Again, welcome back. In this chapter, we said that we have replacement and retention decision, and what the replacement and retention and decisions means. It means that if you were in a place you have to decide whether the process of production, or let me say the economic process of this facilities that you are in, should we continue as it was in the past, or it should need at least, for example, having a little bit change in the process, or maybe you have to reject that one and start a new technology. And so here the decision of replacement and retention will come after. Now, basically the replacement and retention are, we have in this we have in this chapter the replacement are, we have retention and replacement. We have a D and we have a C. This D is called alternative D, and this is challenger. Challenger, it comes after you want to change, you want to challenge what is the existing one. D, it means remain, the defender. Okay, so you have to defend what is there, and you have to, this defender option, it means that it will, you have to stay. Okay, we said that based on the study that we need to decide whether we want to replace or retain retention, we need to have a study. This study is called a replacement study. Replace and retain, it means you have to make a kind of analysis, means economic analysis. The economic analysis that we need to decide whether we are going with D or with C. So we have to make a choice, make a decision. And this decision, it means that you have to make an analysis. The analysis, I mean by the analysis, the economic analysis, we have different types of analysis. We have present worth analysis, we have annual worth analysis, we have future worth analysis, we have rate of return analysis, we have a lot. So, but the main point, or the one that we are taking, or the best suitable one, is to have the decision should be based on the annual analysis to see whether we have to change, stay on the previous decision or change. And that was, D is the current in place reset, and the C is the challenger or the replacement that should be there. We said that the evaluation will be based on a period of time. For example, and by the way, why we are going to, what is the, when you are going to make an annual analysis, the market value is the base, that's the cost, that's the reasonable thing that is, let us think twice to whether we want to replace or retain. And this market value for the new assets will be higher, and within the time value, this market value will come down. It means that if you have a new device now, you can sell it for a higher value now, but for example, next year, it will not worth that. The same equipment will not worth the same value, the same market value. It will worth less than this. That's why we need to change and to make an analysis. Now, the way that we did, and this is as a review, we found first of all the economic surface life, and this economic surface life is very important for us. It means that you have to, for example, N is the number of the years that you may have for first year, for first 2 years, for first 3 years. Every 3 years, this is the periods that we are going to. So maybe in a certain year you are starting with 0 and you are going with the project, for example, for 6 years. Maybe the project will be interesting for you till year 4, and after that you have to pay more because the market value after year 4 it will be very decreasing because of the use of the device or because of the market value. So what we have here, we see that we have a spoon curve, and the spoon curve with will be annual worth value, and will be the number of periods. So in this one, sorry, this is the minimum annual worth value. It will give you the number of the years that you will need, or it will be economic for you to have this project, and it's called economic self-life. Now, what also we solve a problem on that. We solve a problem on how to find this annual worth analysis. We will focus on the annual worth analysis is basically the capital recovery plus A. Now the capital recovery is minus P plus F. This F is the market value or the S, and you have to factorize them for every N. For every N, for example, if N equal to 1, if N equal to 2, if N equal to 3. So we called it as a K. So it will be for K equal to N and so on. And then after that, you have to find the economic surface life within the graphic. So you have to draw this chart, and then you have to find the annual worth of the cost, and then decide what will be the minimum value of that annual worth within the N. Then that N will be the economic surface life. I think this is what a good review for you, right? Do you remember this chapter? Anyone?
Yes.
Okay.
Yes.
Then good. We are going to. So I would like just to remind you that we have solved this problem. We said that we have a new device, a new equipment, and this is going to be its market value when it's new is $40,000. After 1 year of that one, there will be $32,000. After 2 years of using this device, it will only worth $30,000, and so on. After 6 years, it will not worth nothing. Now, what we have to do, we have to find, based on that interest rate, what will be the economic surface life for this equipment. And by the way, this question was one of the questions that in the final exam, I think one of the semesters. So what we have to do first, we have to draw a chart, a curve between annual worth and between the N. So N, we have to take it from 0 to 6. So when N equal to 1, we have a case. The case is that this is the case. We have to pay $40,000, and we will have a market value that's the $32,000, and we have to pay the annual operation cost for that year is $15,000. Now this is gonna be first annual worth. We have to find this annual worth, and we call that annual worth 1. Now annual worth 2 is when you have N equal to 2. N equal to 2, it means that here's the cash flow diagram, 0, 1, 2, and the market value at the year 2, it will be 30,000. Also the previous or the present cost is 40,000. Now also we have to pay 50,000 every year. Now we have another cash flow diagram that's called another I equal to any. We have to find that annual worth and so on. So based on that, you will get these values. Here's the values for the first year, for the second, for the third, for the fourth, for the 5th, and 6th year, there will be total amount. Look at the values. It will going down. It means that within the N, The values was 31,000 and then 27,000 and then 27 also thousand, 26,000. Now after 26,000 there will be 26,800. 700 and 800. It means that I'm going up years. So the curve will be look like this. Now, what is the N? Here's the N. The N, which is the economic surface life, is that that year when we have minimum annual worth value. Here's will be the minimum. Then I can say I have to decide this equipment. It will be economically benefit, or the ideal, the wise decision is to stay with this equipment till number 1, till year 4. After that, you have to change, or you have to sell that equipment for the market. Now here is the economic, and we have to be careful. This is was when we have a certain project, and this certain project was based on the time. Now, what is now for a no study period specified? It means that I have a project from start to end, like what we have in this previous example, from the start, which was year 0, and the end it was year 6. So there is no specific period. For example, the first 2 years. What is the benefit of having this project if I have to decide in the first 2 years? That's called a specific period. Now, in case that we don't have a specific period, it means you have to cover all the end. Then you have to find the annual worth, like what we did, based for every year until we have to find the economic surface life. And based on that, we have to decide whether which is the worth or not. But if there is a study period, for example, you say that, okay, tell me, is this project is worth enough if I till year 2? Now till year 2, it will. We say that till year 4, it will be economic. So yeah, definitely until year 2 will be. But this is you need you to make another decision. If there is a challenger, is there's any other alternatives till year 2 or not? So you have to calculate the present worth for annual worth for this one. Based on our decision, we are going to take annual worth for that period of time and then select the best option or replacement test. Yeah, so yeah, we said that for no period, no study period, we have to find the economic surface life, and based on that, we have to change to select between the challenger and the defender. The defender means you have to stay with the previous one. Yeah. Now, let me go with this example. In this example, we have an economic surface life analysis is performed at I equal to 10%. So I have I equal to 10%. We have for this option, and to obtain the annual worth, and the values was here. The performance analysis study. Now, this is the challenger. It means that this is an option for you to have. This is the defender. The defender, it means that the previous or the old one. Now, look at the question. It doesn't ask us to have any specific period. It doesn't need to say, it doesn't name any year that we need to check. So do you want to stay with the defender or not? So look at the defenders. In the defenders, if you have the annual worth, the device is worth about $50,000. This device will every year it will be market value. This is the annual operation cost. So this will be the annual worth of these two values and the market value. Then it will be about 24,000. So it will be after 2 years, it will be about 18,000, and it will be 17,000 and stop. Now, what that means, it means that the annual worth here and the number of the years here, 1, 0, 1, 2, 3. So after every year, there was an annual worth analysis, and here's the annual worth analysis. So, and there is no more time. So it means that until year 3, you can have this project. The economic surface life for this option is n equal to 3. Okay, now, now what is to obtain the total? Look at the year 3. Year 3 in the Challenger. So for year 3, 0, 1, 2, 3. So in year 3 in the Challengers, the cost is $90,245. While in year 3, which is the economic surface life of this project, is it will cost you 17,307. Now, what is the decision I should make? I should say which one is the best. You have almost the n, or the number of the years in this project is 3 years. So why we have to go with the Defender, and it will give us more cost. So we have to stay with the previous one, with the Defender, because it will not worth then more than 17,000. So the decision is that the annual worth of the Challenger and the Defender is less than this one. I mean by less than in terms of the minus sign. So annual worth of the Challenger is greater than the annual worth of the Defender. So it means you have to go with the Defender. You have to stay with the Defender. So the Defender must be selected because it has better annual worth. Now, this was the first part of this question, and I think we have another thing that we have. If the study, or if we did the same example, we did a study for 1 year only. So the question will be, now look at this, I is 10%, not 20. Yeah. If I have to decide, now the specific period, or it asks me, okay, for till the end of the project, you will say that the Defender will be best economy because it will give us less than annual worth. Now, what about if the n is equal to 1? It means, what about if after 1 year of this the Defender, after of the operation of this equipment, what will be happen after that? That's called the specifying the period. So after n equal to 1, what will be the annual worth of that one? It will be 24,500. After year 4, 1, there will be the cost is 20,000. So what that means to you? Can I get the answer from you? Davin? I'm sorry. Example 4 will be homework for you. Please solve the example that we have here. Means example 2 here. Please solve this one by using, solve this one means you have to find these values by using Excel sheet. So you have to find for me the Excel sheet, or to send me the Excel sheet that's the values here, and also to answer the rest of the questions that we have in example 4. Find economic surface life for each of them and perform a replacement study for now. Now it means that in this case. Okay. Now what you should do, you should find, this is will be for the Challenger. This will be for the market, for the Defender. We have these value, and these should be calculated. How to calculate these ones? They are annual recovery or capital annual worth for the above one, and also these should be found. So your Excel sheet file is to calculate these value first, And how to find the economic surface life? You can say I will say this value, the minimum of these ones will be the economic surface life, and here's will be the economic surface life. So for now, selecting defender now with lower annual worth, the annual worth for the defender it will be 70,000 will be the best over 3 years. Any question?
Sir, for the homework, it is just question 4,
Yeah.
example 4.
Yeah. Question 4 is simply it's question 2. Here's the data in question 2. So here's these data, and here's this data. So there you have to enter these value to Excel sheet. The rest you have to find them. Sorry, these are also this will be included. So these are the just let me make it more clear. The input value are these values. Input. The output should be, you have to make another formula for finding the annual worth in these cells. And then you have to decide which one. Also, you have to have a cell tell you that which one is the minimum with compared to the rest, and the n of this relative to that number, it will be in the economic surface life. And also you have to find for the same for here, and then compare between them. Is the two values between these two values, which one will be minimum, then this one will be selected, the defender or the challenger. This will be your homework.
So the deadline for this homework,
I will upload it today in the Google Classroom, and I will give you a time for that. Okay. It will be very easy.
Right.
Okay. Okay, next time we will take a new chapter, and chapter 10 will be for the next lecture.